Beneath the marble pillars and crowded forums of ancient Rome lay a different kind of empire building, fields rich with sustainable farming secrets. In an age before synthetic fertilizers and high horsepower machinery, Roman farmers cultivated vast territories by observing natural cycles, harnessing ingenious implements, and weaving diverse crops into living ecosystems. From rotating grains and legumes to elevating water with Archimedean screws, these practices sustained millions across varied climates. Still, today's American agriculture has largely forgotten these time-tested strategies. So today, let's uncover 15 of Rome's most effective farming techniques to balance production with long-term soil health. Demonstrated across diverse landscapes and rooted in pre-industrial ingenuity, these techniques reveal agricultural wisdom. Modern farmers are beginning to rediscover tracing centuries of ecological harmony and a rich, timeless legacy. 1. Three-field crop rotation for sustained fertility. Ancient Roman farmers divided their arable land into at least 3 sections and rotated crops annually. One field for cereals like wheat or barley, one for legumes such as peas or beans, and one left fallow. This cycle prevented nutrient depletion, controlled pests, and maximized yield without synthetic fertilizers. Unlike farmers in America, who often practice continuous monoculture of corn or soy, the Romans understood that alternating plant families refresh the soil naturally. Archaeological soil analyses across former Roman estates reveal balanced nitrogen and organic matter levels even after centuries of cultivation, a stark contrast to modern fields that lose up to 60% of organic carbon in only a century of intensive cropping. So by consistently switching between grains and nitrogen-fixing legumes, Romans created a self-renewing system. They observed empirically that following a cereal harvest with bean planting left the ground richer for the next grain crop. Modern research confirms that interspersed pulses hosted bacteria in root nodules, replenishing vital nutrients without industrial inputs, second fallow periods, and green manure to regenerate fields. Rather than exhausting every plot, Romans routinely left 1 in 3 fields uncultivated, allowing weeds and wild plants to flourish for a season. Once these fallow plots were lush, they were plowed under, carefully converting the plant matter into green manure that slowly turned into nutrient-rich humus. Unlike contemporary American farmers who periodically cultivate and replant the same ground, Romans accepted the short-term drop in yield for lasting soil fertility. Modern researchers lauded this practice, asserting that a rested field teaches economy, industry, and justice. Ancient agronomists also advised seeding cover crops like panic grass, turnips, millet, together with legumes in the idle fields. When these plants were incorporated as green manure, they significantly enhanced soil texture, helped the land retain moisture remarkably, and supported diverse soil organisms. This cycle of organic renewal sustained Roman agricultures while ensuring reliable, resilient production across the empire. Third, intercropping, grains and legumes. Moreover, ancient Roman agriculture extended beyond mere crop rotation, employing intercropping by sowing grain and legume seeds in the same furrow. Combining emmer wheat with lentils or peas not only boosted overall yields, but also streamlined harvesting as the pulses matured at the same pace as the cereals. In contrast to modern American practices where individual crop species occupy large, uniform fields, Roman farmers embraced plots in which each wheat ear grew alongside protein-rich legumes. This close planting arrangement produced a lot of benefits. For example, the dense legume foliage suppressed weeds by shading the soil, and the nitrogen-fixing roots fed adjacent cereals, reducing or eliminating the need for man-made fertilizers. Archaeobotanical investigations at different sites frequently recover both lentil and wheat chaff in the same layers, underlining how widespread the technique was. Also, farmers further fine-tuned their seed mixtures according to local soil conditions. In poorer ground, legumes often featured prominently to bolster nitrogen levels, while in richer soils, wheat took precedence. So, by blending species in this way, Roman agriculture balanced risk and reward, ensuring food production remained stable even when dry seasons threatened uniform monocultures. 4. Companion. Planting to naturally deter pests. In place of synthetic chemicals, ancient Romans relied on plant companions to protect crops. They interplanted cabbages with fragrant herbs like rosemary, thyme, and rue, using their strong scents to repel caterpillars and draw in helpful predatory insects. Unlike farmers in America who spray broad-spectrum pesticides over millions of acres, these classical growers fashioned miniature ecosystems in each plot. They applied the same logic to other crops. For example, fava bean beds were ringed by allium species to ward off beetles, while vineyards stood beside rue bushes to discourage vine moths. Pliny's Naturalis Historia has compiled matrices that detailed which plant pairs worked and which ones did not, offering one of history's earliest guides to biological pest management. By weaving aromatic intercropping into their fields, Romans cut crop losses and boosted biodiversity. Modern experiments also validate Pliny's insights, showing that such methods can reduce pest incidence by up to 40%. Thus, spread across an entire estate, these companion plantings created an intricate patchwork of defenses that protected a variety of crops simultaneously, yielding healthier, more robust harvests without leaving toxic residues on the land. 5. Lupinus as a cost-effective fertilizer crop. In his treatise De Re Rustica, Columella extols the white lupin, Lupinus albus, as a remedy for exhausted vineyards and grain fields. These hardy legumes demand minimal labor and thrive in poor soils, their taproots penetrating compacted earth. When plowed in, lupins decompose and release nitrogen, serving as an efficient green fertilizer. This practice transformed tired plots into nutrient-rich soil without external inputs. So rather than relying on synthetic fertilizers common in modern American agriculture, Romans sowed lupins on marginal land immediately after the cereal harvest. The following season's vines and grains benefited from the residual nitrogen consistently surpassing yields from bare, monocropped fields. Archaeological pollen records attest to the widespread practice of lupin rotation across the Roman Empire. Such evidence highlights its role as a foundational element of Roman agronomy. Columella identifies 4 regional lupin varieties and cautions against mid-season grazing, noting that unploughed lupins self-seed and become weedy. His meticulous observations reveal an empirical understanding of plant behavior in past that is absent in today's blanket fertilizer approaches. This refined strategy exemplifies ancient sustainable farming techniques from which modern systems could still learn. 6. Iron plows and animal-drawn deep tillage. Additionally, Roman farmers transformed basic scratch plows into sturdy iron-shared implements set within wooden frames. Developed in the 2nd century BC, this iron share cut through soil more effectively, reducing compaction across multiple passes. Pulled by teams of oxen or mules, the heavier plows forged deep furrows, blending mineral-rich subsoil with the organic top layer. As a result, aeration and moisture infiltration improved dramatically, allowing plant roots to tap into deeper reserves during dry summers. Unlike modern American growers, who depend on high-powered tractors and rapid disc or chisel plowing, Romans prioritized depth and soil health over speed. Their implements, though slower, prepared the ground more thoroughly and sustainably. Also, veteran landowners recorded detailed guidance for adjusting plow angle based on soil texture. They advised a steeper blade angle in clay soils to prevent the iron share from clogging, while lighter, flatter settings were ideal for sandy terrain. By tailoring the plow's tilt to local conditions, they minimized labor waste and avoided frequent tool replacement. This adaptive approach optimized implement lifespan long before interchangeable mass-produced parts existed, ensuring that each estate's investment in blacksmith-crafted shares and frames lasted for seasons. Through these innovations, Romans minimized equipment downtime and kept fields fertile year after year, centuries before mechanized farming emerged. 7. Aqueduct irrigation networks for consistent water supply. Moreover, to support farms in drier regions, Romans engineered vast aqueduct networks to bring mountain spring water into agricultural channels, supplying farms with a reliable irrigation source. Unlike American farmers who often drill wells or install drip systems to irrigate smaller parcels, Roman aqueducts carried water solely by gravity across vast territories. Open channels and raised masonry conduits carried fresh water directly to fields, while strategically placed overflow sluices directed surplus into reservoirs or cisterns for later distribution. This gravity-fed system could irrigate hundreds of hectares without mechanical pumping. In Campania, the Aqua Augusta network transformed once parched plains into productive groves of citrus trees, olive orchards, and grain fields. Such scale was possible only with centralized engineering and state backing, a model missing in today's privately managed farmlands. Maintaining uninterrupted flow required meticulous upkeep. Inscriptions and survey markers, etched along Roman watercourses, laid out regular maintenance schedules to prevent silting and blockages. Landowners themselves bore responsibility for channel cleaning, either by providing labor or paying fees, an early form of irrigation district governance. This collaborative maintenance model ensured that conduits remained clear, water continued to flow, and Roman agriculture in drier territories thrived through coordinated communal effort. These markings are still visible along ancient waterways. 8. Archimedean screws for on-demand water lifting. Also, in areas where fields lay above aqueduct levels, Romans employed Archimedean screws. These were simple helical blades housed in wooden cylinders used to elevate water from canals into higher terraces. Turned by a single operator or by animals walking in a circle, these devices could lift hundreds of liters per hour with minimal effort, solving elevation challenges without complex infrastructure. So rather than electric pumps common on American farms, Roman irrigation drew solely on human or animal power. This low-tech approach offered reliable, steady flow and removed dependence on external energy sources. The absence of electricity also simplified upkeep, since no mechanical breakdowns threatened to halt water delivery during critical growing periods. Screws' modular design dealt with the issue of abrasive silt and pebbles. Wooden flights and central shafts were crafted for quick removal and replacement. Rapid swapping of worn parts prevented lengthy interruptions to irrigation at peak planting and harvesting times. Inventories unearthed in Pompeii list spare components stored near the fields. Moreover, modern experimental archaeology confirms that an Archimedean screw set at a 30-degree angle achieves nearly 80% efficiency, closely matching the performance figures described in Vitruvius's technical writings. This striking alignment between hands-on trials and ancient treatises underscores Roman engineers' sophisticated grasp of fluid dynamics centuries before formal hydraulics emerged. 9. Cisterns and rainwater. Harvesting in dry periods. Beyond aqueducts, Romans collected rainwater in cisterns, lined with waterproof mortar typically built beneath villa courtyards or beside farm outbuildings. These underground tanks captured winter downpours, then fed small gravity-driven channels to kitchen gardens and orchards during the summer months when river levels fell. By storing rainfall on site, growers guaranteed a reliable supply even in drought conditions. In contrast to modern American farmers who depend on municipal systems or large open reservoirs, Roman cisterns blended seamlessly into the architectural fabric of the estate. Columella, in De Re Rustica, recommended covering these tanks to reduce evaporation and installing sedimentation basins at the inlets to trap silt and debris. Such measures closely mirror today's certified rainwater harvesting practices, which also emphasize waterproofing, debris filtration, and evaporation control. Evidence from different towns, like inscriptions and graffiti beside cisterns, warn livestock herders to keep animals away, underscoring how vital water security was to rural communities. Also, archaeological excavations uncover layered sediment deposits that chronicle centuries of maintenance, revealing systematic cleaning and repair efforts. The lasting presence of these cisterns and the records of their upkeep attest to their durability and central role in sustaining Roman agriculture across varied climates. 10th, vineyard training to maximize land use. In his writings, Cato the Elder, a politician and statesman in the mid to late Roman Republic, described an ingenious method of raising grapevines on living tree supports such as willows, poplars, or ash. By training vines to climb the tree's branches, Roman farmers secured their grape clusters above ground level, reducing spoilage from moisture and soil pests. This vertical strategy maximized limited land, as the cleared ground remaining below could support vegetables or livestock grazing. Furthermore, the elevated canopy improved air circulation, decreasing fungal diseases, and kept vines at an accessible height, simplifying pruning and harvesting. Unlike contemporary American vineyard managers who erect elaborate trellis systems of wires and sturdy posts using heavy machinery, Romans used pre-existing trees as natural scaffolding. The resulting multi-layered canopy formed an integrated agroforestry plot, offering shade to understory crops such as legumes, herbs, or pasture plants, a precursor to vertical polyculture concepts. Clearly, Romans combined productivity and biodiversity in a single design without installing manufactured structures. Recent agronomic trials in Mediterranean regions confirm that vines trained on trees produce grapes with significantly higher sugar levels, owing to optimal sun exposure and airflow around clusters. So, Roman growers noted these quality improvements through observation, without the benefit of data loggers or canopy management software prized by elite wineries. 11th, agroforestry. Next, Roman landowners systematically designed their farms as integrated systems, weaving olive groves, fruit orchards, and stands of nut trees alongside fields of grain and vegetables. This agroforestry model yielded timber, olives for oil, fresh fruit, nuts, and cereals, all from a single farm, thereby spreading economic risk and closing nutrient cycles. Unlike American monocrop plantations of vast grain or nut orchards, Roman farms embraced intentionally designed polycultures. The intertwining of trees and annual crops also protected against soil erosion. Deep tree roots anchored steep slopes, while fallen leaves formed a natural mulch that held moisture and prevented topsoil runoff. Modern erosion analyses of ancient landscapes reveal almost no loss of fertile soil over hundreds of years, underscoring the lasting benefits of blending arboriculture with tilled fields. Such integration fostered self-sufficiency on each property. This synergy sustained consistent productivity across diverse landscapes and climates, offering resilience without relying on synthetic interventions. 12th, mulching and composting organic matter. Instead of burning crop residues, Roman farmers gathered straw, vine prunings, and animal bedding to assemble compost heaps. Over several months, these materials fermented, being periodically turned to ensure aeration and uniform decomposition. The resulting humus, rich in organic matter, was then distributed across arable land to improve moisture retention and stimulate microbial activity. While modern American practices often view straw as a byproduct, suitable only for livestock bedding or waste to be burned, ancient farmers recognized its potential in closing nutrient cycles. Ancient Roman texts advised alternating layers of dry and green organic materials to hasten breakdown, a principle reflected in contemporary hot composting protocols. Also, archaeobotanical analysis of Roman farm waste pits revealed elevated pulses of nitrogen-rich organic matter, indicating systematic compost use. Plots amended with this compost regularly surpassed adjacent unfertilized fields in both productivity and drought resistance, underscoring the enduring value of these sustainable practices. 13th, adaptive seasonal scheduling based on climate patterns. Moreover, early Roman agronomists carefully aligned planting schedules with the specific ancient rainfall and frost patterns of each locale. In his agricultural calendar, Varro recorded distinct sowing dates for wheat in Sicily and Gaul, capturing decades of local microclimatic insight. So rather than adopting a single planting window across vast latitude ranges as later American growers often have, Roman farmers emphasized fine distinctions in humidity and temperature. When autumn rains appeared prematurely in the northern provinces, farmers would postpone cereal sowing to prevent seed rot. Conversely, estates in the southern Mediterranean accelerated olive pruning and planting to capitalize on early spring warmth. Passed down through generations, this hard work attests to the high regard Romans held for phenology, harnessing empirical observations of seasonal cues and frost events in detail. Their legacy of adaptive timing and regional specificity predates the uniform USDA planting zones by many centuries, underscoring an enduring agricultural acumen rooted in the rhythms of the land. 14. Small plot subdivision for precision management. Now, rather than vast, unbroken fields, Roman farms were divided into parcels often no larger than a few hectares. This subdivision allowed targeted rotation, varied crop mixes, and precise labor allocation based on each plot's soil profile. Unlike sprawling American fields that stretch hundreds of acres under a single crop plan, ancient farms treated each parcel as a micro-unit. Workers applied different manure levels, adjusted irrigation flow, or altered tillage depth per plot, fine-tuning cultivation in response to localized conditions. Cato's hypothetical farm plan outlines 9 distinct divisions from willow plantations to acorn woodlands, each serving complementary roles. His layout demonstrates a nuanced understanding of land capability that modern precision agriculture seeks to emulate through GPS-guided machinery. 15. Specialized hand tools. Finally, beyond large implements, Romans crafted a suite of iron-tipped hoes, flinted sickles, and hooked pruning knives. Each tool was shaped for a specific task. For example, slender sickles curved for cereal stubble, broad hoes for trenching irrigation ditches, and V-shaped knives for vine pruning. Clearly, unlike American mechanized combines and power pruners, classical farmers relied on handheld precision. Ancient texts provide detailed metallurgy recipes for tool steel, striving for an edge that held up after thousands of cuts. When a tool dulled, smiths reforged it on the estate, ensuring no downtime during critical harvest windows. This culture of craftsmanship sustained a robust local industry of blacksmiths, tool sharpeners, and blade specialists, an ecosystem lost when mass manufacturing supplanted village forges. So, Roman agricultural success stemmed from a deliberate fusion of engineering, biological insight, and communal management, foundations now seldom seen in modern, large-scale American farming. Their rotating schemes, which alternated grains, legumes, and fallow periods, replicated natural cycles to maintain soil health without chemical additives. They also crafted living trellises by training vines on tree frameworks, an ecological support system born of hands-on trial and error. Each method exemplified how local experimentation and environmental principles could coexist. Today, reviving these ancestral practices offers a pathway for farmers to cut synthetic inputs, rehabilitate depleted soils, and establish resilient, self-sustaining food networks. Though centuries separate us from those fields, the agricultural treatises of Cato, Columella, Varro, and Pliny still provide a rich source of sustainable wisdom awaiting modern application. Now, what are your thoughts about these 15 Roman farming techniques? Share with us in the comments section below. We would love to read them. Also, if you like this video, share it with your friends and subscribe to our channel for more interesting content.